Hello, in today's practice lab, I will set up a GRE tunnel over IPsec to remote networks. Now, if you ask, what is GRE in Cisco? GRE stands for Generic Routing Encapsulation. Is a tunneling protocol developed by Cisco systems that can encapsulate a wide variety of network layer protocols inside virtual point-to-point links or point-to-multipoint links over an Internet Protocol network. In this topology diagram here, I have nothing configured yet, so I'll start configuring the interfaces on the routers, and we will walk through everything step by step. And you can find everything in the description of this video. Just on the walkthrough documents, it will walk you through this lab step by step. Now on router 1, enable configure terminal, we'll give it a host name of router 1 here. Now I will configure the interface of gig 00 here for this LAN and this interface here on router 1. So on the interface of gig 00, this is with the IP address of 8.8.8.1 with /24 subnet mask, and I will enable the port with a no shut. Now on the interface of the serial link to the internet of the IP address of 209.165.200.1/30 subnet mask, and enable the port with a no shut command. I will also configure a default route on the router, IP route to any network with this subnet mask and the exit interface on the serial 000 on this interface here. Next, I will work on router 2. Enable configure terminal. The host name here, we want it to be router 2. So here also I will configure this interface on the gig 00 and the serial link connected to the internet on the serial 000 here. So the interface of gig 00, this is with the IP address of 172.16.2.1/24 subnet mask, and enable the port with a no shut command on the serial link of 000. This is with the IP address of 10.1.1.1/30 subnet mask, and enable the port with a no shut command. And again here I will configure a default route to any network with this subnet mask and the exit interface on the serial 000. Next, I will work on router 3. I will configure this interface on the gig 00 and this serial link here connected to the internet on router 3. Enable configure terminal. The host name here, we have router 3, interface of gig 00. This is the IP address of 172.16.3.1/24 subnet mask, and activate the port with a no shut command, and on the serial link connected to the internet, and this is with the IP address of 10.2.2.2/30 subnet mask, and enable the port with a no shut down command. And also here I will configure a default route to any network with this subnet mask and the exit interface of the serial 000. Now also I will configure the internet router. Click simply on the cloud on the internet router. Enable configure terminal. This is the host name of internet. Now on the interface of serial 000, the serial link connected to router 1, the IP address of 10.1.1.2 with the the subnet mask of /32 255 and enable the port with a no shut command. And on the interface or the serial link of 00010, this is connected to router 1. This is with the IP address of 209.165.200.2/30 subnet mask. And notice here, when I enable the port with a no shut command, how this will turn into green, no shutdown. And finally, on the interface connected to router 3, interface of serial 001, and this is with the IP address of 10.2.2.1/30 subnet mask, and activate the port with a no shut command. So I'm done here with the configuration, so simply back now to the topology. Now let's see our configuration so far. So I will run a ping from router 1 to router 2 and router 3 interfaces. Router 2 here to this interface, and on router 3 to this interface from router 1. And ping 10.1.1.1, and it was a success. And the other interface on router 3, and also is a successful. Now, if I attempt to ping, the IP address of the server from PCA, from here, this guy to this server, it should fail because we still did not configure any route yet from this network to that network. So to ping from PCA to the server should fail. And I will cancel it on my keyboard with the Control key and C, and I'll try to ping from PCA to PCC here, and it also should fail. Ping 172.16.3.2. And I will cancel it with a Control C. Now, I will enable security features on the routers, because if I go here on router 2, run this command, also show version, as you can see here, the security is disabled. I want to enable it on all the routers. You can issue this command from exec mode or privilege exec mode to verify. So if I type enable, show version, and also it's showing you it's still disabled. So I will run or activate the security on or enable the security package on all the routers. So I will do it this way. On the global configuration mode, license, license boot, manual C1900 technology package security, and then I will accept it. I'll exit from here and then copy startup config, copy running config to startup config, and then confirm it. Next, I will reload, confirm, and give it a few seconds to reload. And now it is done, and I will run the command show version to see if we enable the security package, and as you can see here, it has been enabled. I will do the same on router on the rest of the router. So I'm done with router 2, so I'll go to router 1, configure terminal, license, boot, manual, C1900, technology package, security. Yes, I accept. Exit from here, copy, running config to startup config, confirm, then reload and confirm. I'll do the same also on router 3. License, boot, module, C1900 technology, security. Yes, I'll exit. Before I copy the running config to the startup config, I'll do a WR and then reload, confirm, and I will jump to the internet router, do the same, exit, license, boot, module, C1900 technology package, security, yes, exit, WR, reload, confirm, and we are done. I will go back with the arrow here to the topology diagram. Now I will start configuring IPsec. First, I will identify interesting traffic on router 1. I will configure access control list, extended access control list, I'll give it the number 101 to identify the traffic from the LAN on router 2 and router 3 as interesting. This interesting traffic will trigger the IPsec VPN to be implemented whenever there is traffic between router 1 and router 2 or router 3 LANs. All other traffic sourced from the LANs will not be encrypted. It's because of the implicit deny any. And there will be no need to add this to the statement because it is implicitly denied. So on router 1, I will create access control list, enable configure terminal, access list 101. I want to permit the IP, the network of 8.0.0.0 with the inverse subnet mask of 0.255.255.255, the network of 172.16.2.0 with the inverse subnet mask of 0.0.0.255. I will configure another access control list 101 to identify traffic from the LAN on router 1 to the LAN on router 3 as interesting. So on router 1, access list 101, I want to permit IP to the network of 8.0.0.0 with the inverse subnet mask of 0.255.255.255 with the network of 172.16.3.0 with the inverse subnet mask of 0.0.0.255. Enter. Next, I will configure ISACAM phase 1 properties on router 1. Now, what does ISACAM stand for? Internet Security Association and Key Management Protocol. Internet Security Association and Key Management Protocol. This is a protocol defined by RFC 2408 for establishing security association, SA, and cryptographic keys in an internet environment. Now I will configure the crypto ISACAM policy 101 on router 1 along with a shared crypto key, and then in this example I'll use Cisco as the key among the routers. I will configure only the encryption. I will not configure the default values, only key exchange method and Diffie-Hellman. Now, when we go over, you will see that I type ESP. So what's ESP? It's encapsulating security payload. Its IPsec uses encryption technology to provide data confidentiality, integrity, and authenticity between participating peers in a private network. Cisco provides full encapsulating security payload, ESP, and authentication header, support. Now, also you will see the AES.
Looks like there's a problem.
What's AES? Advanced Encryption Standard. The Advanced Encryption Standard, AES, computer security standard is a symmetric block cipher that encrypts and decrypts 128-bit blocks of data. Standard key length of 128, 192, and 256 bits may be used. And also you will notice that while configuring IPsec, I'll use secure hash algorithm, SHA. Description, secure hash algorithm, SHA. The SHA-1 hash encryption algorithm specifies a secure hash algorithm, which can be used to generate a considered representation of a message called a message digest. Also, we will run the hash message authentication code, HMAC. This is a cryptographic artifact for determining the authenticity and integrity of a message object using a symmetric key and a hash message digest. The HMAC or HMAC can be based on message digest algorithms such as the MD5, SHA-1, and SHA-256. Now, on router 1, from the global configuration mode, a crypto ISA camp policy 101 for the encryption AES, for the authentication pre-share, and we'll use Diffie-Hellman group 5. I'll exit from here. And next, I will generate ISACamp key for each peer of router 1. So we have two peers here for router 1. The peer here on router 2 and this peer here of 10.1.1.1 on router 2 and 10.2.2.2 on router 3. So back to router 1. A crypto ISACamp key. In this example, I'll use Cisco. And for the address of 10.1.1.1 and with the upper key on your keyboard just for the peer of the address of 10.2.2.2. Next, I will configure the ISACamp phase 2 properties on router 1. I will create the transform set, router 1 set, and for router 2, I'll use router 2 set, and for router 3, router 3 set. To use ESP AES and ESP HMAC. Then I will create the crypto map for router 1 dash map, router 2, I'll use router 2 map, and for router 3 map. And that it will bind all of the phase 2 parameters together. I will use sequence number 101 or 101 and identify it as an IPsec ISACamp. So from the global configuration mode here on router 1, crypto IPsec transform set router 1 dash set ESP dash AES and ESP SHA HMAC. For the crypto map router 1 dash map all caps 101 to use IPsec ISACamp. So now we have two peers here. Set the peer of 10.1.1.1 and 10.2.2.2. These are the two peers for router 1. The peer here on this interface of 10.1.1.1 and 10.2.2.2. Back to router 1. Now, I will set the transform set router 1 as router 1 dash set all caps, and to match the address of 101. I'll exit from here. Next, I will configure the crypto map on the outgoing interface. I will bind router 1 map, crypto map, to the outgoing serial interface on this serial interface here. So on router 1, the interface of serial 000, a crypto map router 1 dash map. Enter. So now I'm done with router 1, so I'll jump on router 2. First, I will create the access control list. Enable, configure terminal, access list 101. I want to permit the IP to the network of 172.16.2.0 with the inverse subnet mask of 000.255, the network of 8.0.0.0 with the inverse subnet mask of 0.255.255.255. We are done configuring the access control list. Next, I will configure here, run the configuration router 2, crypto ISACAM policy 101. For the encryption, AES, for the authentication, pre-share, and to use the Diffie-Hellman group number 5, and I'll exit from here. Next, I will generate the key, crypto ISACAM key. In this example, just like what we use on router 1, we'll use Cisco for the address. So before I type in the address, is this interface to router 2 on 209.165.200.1. Enter. Next, I will start with phase 2. Crypto IPsec transform set router 2 dash set ESP dash AES ESP dash HMAC. The crypto map now router 2 dash map all caps. We're using 101 just like we used with router 1 IPsec ISAC map. Now the peer of 209.165.200.1. This is the peer here. Now the transform set router 2 dash set, and to match the address 101. Enter. And I'll exit from here. Now, I will configure the crypto map on the outgoing interface. This is the outgoing interface on router 2. I will bind the router 2 map, crypto map, to the outgoing serial. So back to router 2, interface of serial 000, crypto map router 2 dash map. Now we are done with router 2, so let's jump on router 3. First, we will configure the access control list, configure terminal access list 101. I want to permit the IP of the network to the network of 172.16.3.0 with the inverse subnet mask of 0.0.0.255 to the network of 8.0.0.0 with the inverse subnet mask of 0.255.255.255. Enter. I will start with the phase 1. Crypto ISACAM policy 101 for the encryption AES and the authentication pre-share, and use Diffie-Hellman in group 5 for in this example. Now I'll exit. Next, I will work on generating the ISACAM key, crypto ISACAM key, just like what I use on router 1 and router 2. I'll use the key up Cisco, the address of 209.165.200.1. Enter. Now I will start on page 2, crypto IPsec transform set router 3 dash set all caps ESP AES ESP dash SHA HMAC. Now the crypto map router 3 dash map all caps for map 101 to use the IPsec ISAC cap. Now the peer on router 3, which is here on router 1, this is the peer 209.165.200.1. 209.165.200.1. Now I will set the transform set, which is router 3 dash set all caps, and this to match the address 101. I'll exit. Now I will configure the crypto map on the outgoing interface for the router 3. This is the outgoing interface here on this interface. So interface of serial 000, crypto map router 3 dash enter. Next, I will work on configuring Gre tunnels over IPsec. First, I will configure the tunnel interface of router 1 to router 2 from here to here. So on router 1, from the global configuration, the interface of tunnel 0. This is the IP address of, as you can see, here with the blue, tunnel 0, the IP address of 192.168.0.1/30.255.255.255.252. Now I will set the source and destination for the endpoint of tunnel 0. So the tunnel source on the serial 000, this is the source here, and this is the destination of 10.1.1.1. Tunnel destination 10.1.1.1. And I will configure tunnel 0 to move the IP traffic over Gre. Tunnel mode Gre over IP. Next, I will configure Gre tunnel over IPsec. First, I will configure the tunnel interface of router 1 to router 3. So we are still on router 1. We configured tunnel 0 to router 2. Now on router 1, the interface tunnel 1, and as you can see here, this is the IP address. IP address of 192.168.0.5/30 subnet mask. I will set the source and destination for the endpoint. So the tunnel source on the serial 000, tunnel source serial 000, and the tunnel destination on 10.2.2.2. This is our source here, and this is our destination here. Now I'll configure tunnel to move the IP traffic over Gre. Tunnel mode Gre over IP. Next, I will configure tunnel 0 interface of router 2 and router 3. So now on router 2 here, I'll exit from here from the global configuration mode. Now interface tunnel 0, and as you can see, this is the IP address of tunnel 0 on this site, on the router 2, and the IP address of 192.168.0.2/30 subnet mask. And the source and destination for the endpoints, tunnel source, serial 000, and the tunnel destination on the 209.165.200.1. This is our source, and this is our destination. On router 2, I will configure the tunnel to move the IP traffic over GRE. Tunnel mode GRE over IP. Now it's time to work on router 3 from the global configuration mode, interface tunnel 0, and this is with the IP address of 192.168.0.6/30 subnet mask. The tunnel source on the serial 000, and the tunnel destination on the 209.165.200.1, and to move the traffic over GRE over IP. Tunnel mode GRE over IP. Now I'm done with the configuration from router 1 to router 2, from router 1 to router 3, and router 3 to router 1, and router 2 to router 2 to router 1. Now I will configure a route for private IP traffic. I will define a route from router 1 to the network of 172.16.2.0/24 and to the network on router 3 of 172.16.3.0/24 using the next hop address on the tunnel interface. So here on router 1, the global configuration mode, so IP route to the network of 172.16.2.0/24 subnet mask. And now from here to here, and our next hop will be this IP address. This is the next hop address of the tunnel. So it is 192.168.0.2, and another route to the network, to this network of 172.16.3.0. So this will be 3.0/24 subnet mask, and the next hop will be 192.168.0.6. Enter. Now, I defined the route here from router 1 to router 3, 2 and 3. Now on router 2 to router 1. On router 2, I will define a route from router 2 and router 3 to the network of 8.0.0.0/24 network using the next hop address of the tunnel interface. So from the global configuration mode, IP route to the network of 8.0.0.0 with the subnet mask of 255.255.255.0, and the next hop will be 192.168.0.1. Enter. Now on router 3, from the global configuration mode, IP route to the network of 8.0.0.0/24 subnet mask, and the next hop 192.168.0.5. Enter. So now let's verify connectivity. So I will ping the server from PCA and PCC. I'll ping from this guy to the server and from this to here. So on PCA, ping 8.8.8.8. It should be successful. And it is. I'll try it again, and here we go. So the ping from PCA to the server is successful. Let's see from PCC, to the server. Ping 8.8.8.8. It should be also successful. And it is. Now, but if I attempt to ping from here, PCA to PCC, it should not be successful. It should fail because there is no tunnel between these two lines, between this line here on router 2 and this line here on router 3. So let's try. Ping 172.16.3.2. It should fail. And it did not go through. So I'll cancel it by hitting Control-C on the keyboard. So this is our lab here. We configured Gre tunnel over IPsec, and I configured routes and the interfaces. Run when you are done. When you reach this point, just go to the routers, all of the routers, and run show run, show IP, show crypto IPsec SA, show crypto ISACAMP SA, just run as many show commands you can think of and just study the results here to get an idea what you did so far. Just follow the description at the end of this video, download the walkthrough documents and download the files for the packet tracer and do this lab on your own and just follow the steps and you will do good. If you have any comments, suggestions, please write me and I will be happy to answer you back. And please, if you like this video, share it on your Facebook. And if you want to have a look at all the videos I made so far, just check the playlist on YouTube or my page on my Facebook page. Go to the labs. All the labs I did so far are there. Thank you so much for watching, and I'll see you soon in my next video. Have a nice day.